Okay, now that we've learned a few skills here, we know how to calculate Gini, how to calculate costs. So now let's figure out how to find the optimal split. First, we will assume that we're looking at just one column. So we suppose we'll start with the column MPG. We'll start with the column MPG, and then the other thing we're going to do is the following. We will work on a set of indices, because what we need to do is we'll get this data set X, this data set, right, where we define Y's at column C, and then X is all the other columns. But we need to learn how to split this data set vertically, right? So basically we will have this, we'll find some threshold value for MPGs, for instance, in this case, and we need to be able to split them. But when we split this data set, we will split them by indices. So we'll start with a set of all the indices, and then we will separate them into left and right hand side. How do we get the indices? That's very easy. We already have X and Y, so we can get indices of any of them, right? Index. So this will be the indices, you see. So we'll put them in indices. We'll put them into the indices, or well, maybe just for shorter, let's just call them IDX, right? So these are all starting indices. So we can actually now look at that column which we are going to use as a feature. So we said that we will start with with column, and then we will be getting all their indices, right? IDX. So we could do something like this. If we do something like that, look, we pulled only the MPG column, and we got all the indices, 32 of them here, right? So for instance, this is the idiom we can use further in our code. Now we need to split this IDX into two parts somehow, and we need to do it in such a way that we can minimize this left and minimize this total weighted sum of left hand side impurity and right hand side. So we will be having the indices on the left and on the right. So how are we going to do it? One way to do it, as we said, is the following. So we are going to with column MPG, and now we need to find the threshold, how we divide them. So how do we find this threshold? So let's think of this. I mean, the columns are coming in some arbitrary order. See, you see, it's increasing, then it's decreasing, and so on. What we probably want, we want to sort these MPGs in certain order. And not only that, well, let's first sort and then see what happens, right? So we got these MPGs, and how do we sort them? We can sort them the following way. We can sort the values as follows. There is a function called sort values, right? So we'll sort values. We actually could do it the following way. We don't even have to. So we'll get all the indices, we'll sort the values, but we will sort them by the column, right? By the column. And once we've done that, we want to get an index of the sorted array. So let's see. Okay, sort values, X, sort values. What is wrong here? Let's see. None of the index are in columns. Right. Let's do this. Okay, this worked, right? Somehow. Lincoln Continental. So let's see, Lincoln Continental, 10.4, the smallest, right? The second one, Cadillac Fleetwood, also 10.4. So it did sort. The first one didn't work when we were getting the indices first. Right, right. The mistake was the following. We can't say IDX like this, right? Because this is reserved for columns. So in order to do IDX, we had to say loc. And we'll locate them by index and then sort by value and then get all the indices, right? We got something like this. Great. So this works. I'll explain why we want this. So these are sorted, and that is great. But one thing, okay, so suppose they're sorted, and now how do we pick the thresholds? Like, what are the thresholds we're going to try? So one thing which I suggest we do is the following. So once we got these indices, if we put these indices into, we call them sorted values, right? Sorted indices. Let's just call it like this, right? So these are sorted indexes. If we get this column which we're looking for, and then the index which is sorted indices, we are going to see the following: 10.4, 10.4, and so on. So how do we pick the value? So I suggest we do the following. Why don't we get the values right in between? They're already sorted, so let's get right in between, like an average between 2 points. So for instance, if it's 10.4 and 13.3, we will get something in between. What are we going to do with these two, with repeated values? So the easiest way to deal with this is not just to get sorted indices, but also get sorted indices which are unique, okay, for unique values. So how are we going to do it? One way to do it would be the following. We will get this column, right? So we will do the following. Okay, we'll keep that. So we get this column, but then we'll get the unique values of this column, right? So if we did something like this, right, it's arbitrary things, but there is no repetition anymore. The 10.4 only is once, right? So we got the unique ones. That is great, and then we can sort them. Right now we got the unique values sorted in ascending order. Now let's for the thresholds which we are going to try, we will use the thresholds right in between all of these values. Right, so how are we going to do that? So we will call them splits, right? So splits would be the value right in between. So for instance, we could take something like this, right? So this was sorted, was a unique sorted values, right? And we could do the following. So for instance, if we got unique sorted value of 0 and plus unique sorted value of 1, and then if we got right in between of them, right, what we would get, let's see. And let's actually print you see we have 10.4, 13.3, so 11.85 is right between 10.4 and 13.3. So this would be one of the values we will try, and then we'll try value in between 13.3, 14.3, and so on. So that's how we will be splitting our data set, right? So we need to get these splits, and this formula actually gives you an idea of how could we do it. And what we're going to do is, the easiest thing to do here is the following. So let's define our splits, right? So we could say something like this. Unfortunately, this is not a NumPy array, so we can't run an operation on all of them at once. So we have to do it in a loop, right? So the way to do this in a loop would be the following. How do we do it in a loop? We will do it the following way. We can use the list comprehension again if we wanted. So for instance, we could do something like this. For I in a range, right? And the range would be length of you. Sorry. It was actually giving me a very good hint, right? So I'll do tab. So whenever I'm pressing tab, it just uses this whole suggestion, right? So look, it already knew what I wanted to do. And now all I want to do is the following, right? I and then I plus 1, right? So what did I do? And then let's do it as a list comprehension. Let's see what happens. I hope it works. It seems to work, right? 1185, 13.8 is right between 13.3 and 14.3. What's going on? How is this working? Well, the way it's working is the following. Unique sorted values were all these MPG values, right? Column was MPG. I got all the values of MPG, sorted them, and only looked at unique values, and then I'm taking everything in between. So here what I'm saying is I'm running I through an entire range of values. So len USV tells me how many points are inside this USV, and obviously I'll have 1 point less, right? So if you have 32 observation, then there will be 31 middle points, obviously. So, well, in this case, it's not 32 observations because we're looking at unique ones. So it's fewer, but anyhow, we will have midpoints are exactly the length of 1 less than the full USV. So that's why I'm running the length minus 1. And then I'm getting all the indices. And for indices, I'm getting the first value of USV and the next one, right? I plus 1, and getting half of them. So, and then I'm saying create a list out of all of these. Okay, so this kind of a list would be our midpoints. So why don't we call this function splits, right? So we can call this function get splits. So let's do this, get splits, and we'll create lambda again. Lambda, what are our, nothing, right? It's just one value, USV, unique sorted values. And this should work, but we will make it even maybe simpler, right? So we will actually instead of having unique sorted values, we will say all I need is basically my not even unique value, just the column values, right? So I will do the following. I'll say, well, then I repeat several times. So maybe let's not do it. Okay, anyhow. So if I give it a unique sorted values, it's going to do the split for me. So how do we know it's going to work? Let's see. We'll do splits equal get splits, but instead of USV, I will say this is going to be this, right? Sorted x call whatever, right? So I'll give it here. X call unique, right? So this should work. Splits, splits, splits. Yeah. This works, but I don't like it. So I don't want to be always calculating it myself, right? So I just want to supply my x and indices to it, and then I want it just do the thing for me, right? So instead, I will say the following, right? Maybe I'll say x. I'll say indices idx, right? Idx. And then I will say column. And if I give this all, then I should be able to just plug this thing. So can I just say USV equals Control V? Right, so let's create a function then. Let's not do this, right? So we'll create a function, we'll call it it splits. Instead of lambda, like it looks like it wants to be a function. So we'll make it a function. And then return. So this should work. Get splits, but now I have to supply these. Works, right? Okay, great. So what did we accomplish? What we accomplished is the following. If you give me the x, value, right, then I will get all the split points. So I'm given a data set like this, and so I say that for column MPG in this whole data set defined by indices, I know now I have all the possible candidates for the threshold. So these are what I call splits, are basically candidates for thresholds. So you see the algorithm now. I'll just try all the candidates and then see which one will produce the best split. So that's all I'm trying to do. So let's think of how could we do it, right? So one way to do it would be the following. So let's just leave this and then create a new code set. We're going to do the following. We'll say, well, without even trying to make it a function, we'll say for all tk. So this is a tk in splits, right? For all tks in splits. We just got the splits. We want to try to calculate the Gini function and all that stuff, right? So we got this tk in splits. Now we will try them one by one. So how do we try it? So the way we're going to try it is the following. We need to get all the left indices. Indices which will go to the left, right? Left indices. Maybe I'll just make it shorter. Left indices, right? And they're equal to, look, I mean, it already calculated everything. Somehow it knows everything that I want to do, right? So look, I'm saying it's all the indices where x call is lesser than tk. Wow, it already knew it, right? Now, how do I calculate? So I got all my left indices. Did it do it right, though? X call, that is fine, right. Right. The next thing I want to do is the following. Now I want to be able to start calculating my frequencies and everything, right? So look, it's suggesting me a lot of code here. So what is left frequencies? Let's see. So somehow it knew I wanted to do this. I didn't type it, as you saw the generative AI was doing it. Well, it wants to apply frequencies to y, l, dx and classes, and that's exactly what I want to do, right? So I want to calculate frequencies of each class on the left-hand side and on the right-hand side. See, my indices are defined based on the column, which was MPG. But classes, frequencies of classes, are calculated based on the column cylinder, which is in my y variable. Okay, because that's how the classes are defined. And now I can calculate the Gini, right? How can we calculate Gini? Look, it even Gini left, Gini right. So let's see, is it true? Yeah, it should be able to calculate Gini left, Gini right this way. And then I should be able now calculate the cost. And the cost is going to be, wow, this generative AI, clearly they trained it on GitHub code. So that's how it knows, sort of it guesses what is my next thing to do. Well, what's going on here is the following. So we have Gini left divided by length of the, well, this is wrong, right? So this is a little bit wrong here, I think. Oh, no, actually it's not. See, it's a total length of an index, this, right? We are basically, we're trying to implement this formula, right? Left over the total length, which is total length, and then Gini right, and so on. Wow, that's interesting. So what we want is not just the cost, I also want to know what is this TK here. So great, right? So this is the cost, but also I want TK. Very good code suggestions from AI today. So it's doing all these codes and so on. Right now, okay, so I was able to calculate, it seems, all the costs, but now I need to pick the optimal, like the lowest of these TK. So how do we do it? There's many ways of doing it, and I'll go with the easiest one, right? So I'll go with this way. So I want to minimize the cost, right? So I'll go with the cost min. Actually, I'll do it even simpler than that. We'll do it this way. So we calculated the cost, we're printing the cost, but we will do the following. If, right, cost minimum is none, right? Or cost less than cost min, and then cost tk. Wow, that is interesting. So let us see. Will this code work? Let's see. But we need to cost minimum, right? Split min. I don't want to call it split min. I'll call it tk min. So let us see if it works or not. Okay, it didn't work, right? Because cost min is not defined. Okay, that's great. We actually can check whether cost min is there or not, but the way I'll do it is simpler. I'll just do it this way. Cost min equals none. So it's nothing. And that way I can check it, all right, this way. Look, it worked, right? So I said cost minimum is none. So when I calculate my cost and tk for the first time, I'll come to this if statement, and because cost minimum is none, I'm going to set my minimum and tk threshold minimum to whatever the current values of tk minimum and cost are. But then subsequently, once I start iterating through tk, I will only be updating cost minimum only if cost is less than cost minimum, and that way I will find the minimum cost. And let's see, cost minimum is 0.3197 and tk minimum is 21.2. That is interesting, right? 21.2. Well, I guess it probably is right. One thing we could do, so we did this, we could do something else. We were calculating these other values, and we can actually preserve them too. So for our function, they can be useful too. And we'll talk about it next.